Hello everyone. In this video, we will be multiplying rational expression and this is the first part. Before we solve this first example right here, let's have a review on the basics of multiplying rational expressions. We remember that in multiplying rational expression or pretty much multiplying fraction, we are supposed to multiply them across. Let's take this general formula right here. If we have A over B times C over D, in order that we can multiply this two rational expression or these two fractions, we multiply them across. So A times C, so that's how we got A times C right here. And we multiply at the same time the two denominators, B times D, and that's how we got BD. Now, we remember that this is only true when B is not equal to 0 or D is not equal to 0. Because then if any of this is 0 or both of these are 0, so then we can go ahead and say that this expression becomes undefined because dividing by 0 is undefined. Okay, in order that we can multiply these two expressions right here, there are steps that we need to follow. The first step is to factor out both the numerator and the denominator. So in this problem right here, I'm gonna show the work on the side here where I factor both the numerator of the first rational expression and the denominator and both of these two as well. So then I'm going to have 4 boxes here, and this is where the 4 work for this the 4 work for each of these, factoring them out. So we're going to start with the numerator here. So I go ahead and write this as 15x squared minus 12x. So I will factor this out. So I will factor out the GCF. So we're going to start with this one right here first. So 12x, I can go ahead and factor this out. So this would be 3 times 2 times 2 times x. So I'm going to write x right there. And then this 15x squared can also be factored out as 3 times 5 times x times x. So then we can go ahead and say that the 3 and the x are the GCF. So I'm just going to write it down here, GCF. And so that is 3 times x is 3x. So then we go ahead and factor out the GCF. So I'm gonna write 3x outside the parentheses, and I will figure out what do I write inside the parentheses. Now there's a trick. We start with the 15x squared. Whatever is the leftover, that's the one that we write here. So the 5 and the x. So I'm gonna write 5x. And then whatever's the leftover, that's a minus. Whatever's the leftover for 12x, that's the one that I will write here. So that would be 4. So then this is the factored form for this one right here. So if we do the distributive property right here, 3x times 5x is 15x squared. 3x minus 4 is negative 12x. So then I can go ahead and change this 15x squared minus 12x into this because they're just equivalent. So that is 3x times 5x minus 4. So then I will do the same step for this. I'm going to write it down here. So that would be 2x squared plus 3x. Again, I will factor this out. So determining the GCF for this, we're going to factor the 3x. So that would come out 3 and then times x, and then I can go ahead and factor these out as well. So 2x squared would be 2 times x and x. So we can go ahead and say that the common factors would just be x. So I can go ahead and say that the GCF is x, and so we can go ahead and factor out the x, which is the GCF. So x times, we can go ahead and figure out the leftover, or you can divide this to this one right here. So if we divide 2x squared divided by x is 2x, or you can go ahead and see whatever the leftover is. We're going to write that down here. So that's 2x. And the leftover for the second term, that's a plus 3 is the leftover. And this makes sense because if we multiply x times 2x is 2x squared, x times 3 is 3x. So then I can go ahead and rewrite this up here. This one would come out to be x times 2x plus 3. So then I go ahead and do the same thing for all these two right here. I'm gonna show the work on this side. Okay, so after we did the first step, we go ahead and move on to the second step. The second step is to simplify. In order that we can simplify this, we can actually use the division by itself property, which states that if we divide a number by the number itself, then the quotient is 1. Or pretty much we can go ahead and cross out those like terms. So I can go ahead and cross out this 2x plus 3 and 2x plus 3. Again, we remember that when we cross out, it is not 0, but instead it becomes 1. Again, that is division by itself property. So then I can go ahead and cross out at the same time 5x minus 4, 5x minus 4. So then the leftover here would be 3x times 4 is 12x. So I can go ahead and write 12x right here. And then the denominator, we have x left over and 6. So that is pretty much 6x. So then we can simplify this some more. We can get the factor of 12x, so that would be 3 times 2 times 2 times x, and the factor of 6 would be 3 times 2 times x. So then we can cross out the 3 and the 3 and then the x. So then we are left with 2. So this two rational expressions, when multiplied together, would come out 2. So I'm just gonna write 2 over there. I'll put this inside the box. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. Again, the first step is to factor out both the numerator and the denominator of each of these rational expression. So I'm just gonna show the work on the side right here. Okay, so we're gonna start with 3x to the 5th plus 3x to the 4th. So we will factor out the GCF. Okay, so I factored them out, both the numerator and the denominator. That's the first step. Now, the second step is to simplify. In order that we can simplify this, we are going to use the division by itself property, which states that if we divide a number by the number itself, the quotient is 1. Now, we can actually just simply cross them out, but then again, we remember that when we cross out, it doesn't come out 0, but instead it's equal to 1. So then we can go ahead and cross out this x minus 2 and x minus 2. Then we can cross out the x plus 1 and x plus 1 as well. So the leftover here would be this 3x to the 4th. So that's the one that we have on the numerator. And then we have the x plus 1. So I can go ahead and write that down here. So 3x to the 4th times x plus 1. So that's the leftover because all the rest becomes 1. And then the denominator would come out x squared, and again we still have the x, so that would be another x right there because we're multiplying them across. So that we can go ahead and simplify this further, we can expand it, so we can cross out the like terms. So I can go ahead and say that this is 3 times x times x times x, and then there are 4 of them, and then I keep the x plus 1. And then this is 2 x's, and then there's another 1x. So pretty much there are 3 x's at the bottom. So that again, we cross this out. So these 2 gets crossed out, these 2 gets crossed out, these 2 gets crossed out. So we are left with 3x, and that is over 1. So there's 1 right there, but we still have the parentheses x plus 1. So I can go ahead and write x plus 1 right there. So then the final answer that we can have here would be 3x parentheses x plus 1. And this is the product for these two rational expressions. When they are multiplied together, it will come out like this. Or we can actually rewrite this as using the distributive property. We can distribute the 3x to the x and then the 3x to the 1. This can come out 3x squared plus 3x. It's just the same thing. Did you get the same answer as this? Good. Perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!